Hello, welcome back to chemistry. This is Mr. Arnold coming back live at the school here, I guess, this morning. What we're going to do today is we're doing a pre-test. We're going to take our test on Wednesday this week, which will be the 6th. So Wednesday the 6th. So this little video here is for those who need help reviewing a little bit, and so we're going to start off by doing some of these problems. Now, when you do these problems, the first thing you have to remember is we have a pattern, we have a map we have to follow. So let's get this map down, and let me move out of the way a little bit, and let's see what happens. How about right here? Okay, Chad mixes 3.2 moles of nitrogen reacting with sufficient H2. How many moles of ammonia, NH3 is ammonia, will be produced? So we're going to start off by balancing this equation. So that's a good place to start. Remember, when you're balancing an equation, the first thing you want to do is you want to find something that's different. I'm focusing in on those ends, and that I see two ends on one side, and I also see one on the other. So I'm going to put a 2 on this side here, and that will give me 2 ends on the right, which gives me 6 H's. I put a 3 in front of here, and by golly, that is a balanced equation. So there's a good place to start. Now we have a map, and that map follows this pattern every single time. I'm going to write it up above. It looks like I have the most space up here. So I'm going to write right up here above. And that pattern goes like this. Grams, and that's grams of given, to moles, and that's moles of given, excuse me. And then we go to the other thing, to moles, and that's moles of the unknown. And then we go to grams, and that's also grams of unknown. So we have the unknowns on the right side, and we have the givens for a little bit, but I'm back right now, so I'll see where I left off. I think I just had written up a map here. Grams of given, moles of unknown, and grams of unknown. So remember that pattern, right? That's going to be the same pattern for this whole thing today. So the first thing we want to do is write down our givens, and I like to do that above the balanced equation. So let's see what we have here. I'm going to do this in green. We have 3.2 moles of nitrogen. Okay, now that's not grams, right? Oh, I did it in the wrong color. Oh, darn it. 3.2 moles of nitrogen. I guess I don't have to write nitrogen because I wrote it above nitrogen. Okay, now the reason I changed colors is because 3.2 moles is the given. That's what I'm starting with, right? So I wrote it in red, all right? And so it's not grams this time. It's going to be moles. So remember, if we have something else given besides grams, say we have moles given, then we can skip that first step. We don't have to backtrack. We're just going to skip that step that we don't have. All right, now what are we trying to find? It says it reacts with sufficient hydrogen. That just means it has enough to react with. How many moles? So there's moles again. So this is supposed to be green, right? Yep. So how many moles of ammonia do we have? So we're trying to find moles here. All right, now, again, we're not ending in grams, we're ending in moles. So we don't have to go to that last step. So we could just cross that out. And obviously from my little table I gave you, is a hint. Now, on the real test, maybe I'll put all 4 on there. I don't know. But we have 2 steps, right? The first thing that goes in is the given moles. So we're going to put that in there. So we have 3.2 moles of nitrogen. And what are we trying to find? Moles of NH3. Now, I didn't write any numbers down for that moles yet, right? Because I'm not going to do that yet. I'm going to wait. All right, now, what do we have to do? We have to cross out. We have to cross out. So what goes on the bottom? Moles of N2. All right, now we're ready for numbers. This is the mole-mole ratio. Where does the mole-mole ratio come from? The balanced equation. So that's what we have to do now. So look on the balanced equation. Right? Go over here. Oh, looky right there. See that? N2. There's one N2, and there's 2 NH3s. Make sure you put them in the right spots. So for ammonia, the 2 NH3s, 1 N2. All right? That's what you do. That's it. Okay. And so we plug this to our calculator. It's going to be 3.2 times 2 divided by 1. You don't have to write that in. Well, of course, that would be 6.4 moles of NH3. Okay. All right. Moving on. This was an old test. So I just put the kids' names in. I like to do that because it's funny. So Kira wants to produce 2.75 moles of potassium chloride. Okay. So that 2.75 moles, that's our given. How many grams of potassium chlorate will be required? And so I'll put this in red this time. So grams of potassium chlorate. And that's our unknown. Okay. We're going to start off by write those above our thing. And again, I'll try to stay color-coded with what I have. All right. So our givens, right? I'm going to put it over here. So we have grams of given, moles of given, and we'll switch colors, to moles of unknown, and to, I know you can't do this very well with yours, but I can slide this over, to grams of unknown, right? And that's our pattern again. Now let's look what we have. We have moles are given, so we don't have any grams of given. So what are we going to do? We're going to take them, we're going to cross out our first step. And now we have moles of given, moles of unknown, grams of unknown, and we're trying to find grams, so that'll work out just perfect. Okay, so we have that set up. Again, I like to write them above the balanced equation, so I will do that right now. So green, we have 2.75 moles of KCl. 2.75 moles. Now put that label in there so you know what it is when you look later. And what are we trying to find? Grams. I like to put a question mark there just so I know I'm looking for that. All right. Now, this equation's not balanced, so we have to find the oddball. There it is. Look at those oxygens. We have 2 and 3. So if we have 2 and 3 oxygens, where's my thing here? Knock my mouse off the table. So if we have 2 oxygens on this side and we have 3 oxygens on this side, we have to fix that. And the best way to do that is just by making the least common multiple 6. And so what I'm going to do is I'm going to put a 3 over here. And I'm going to put a 2 over here. All right? And that fixes those oxygens. It makes it 6 and 6. But that also changed my KCLs on this side. Now I have 2 KCLs, and so I have to fix that also. So I'll put a 2 in front of there, and my equation's balanced. All right, let me slide out of the way. Okay, that looks pretty good. All right, now, remember our our given. So we have moles given, so we're going to start with moles. So we have 2.75 moles of KCl. What are we going to next? Right? Moles of unknown, grams of unknown. So now we're going to go to our moles of unknown. So moles of KClO3, grams of KClO3. All right, if I'm going too slow and you know how to do this, you don't have to watch it. I'm going to have the answers posted too. I'm going slow for the people who need to watch. All right, now we need to cross out, right? So just the labels. Moles of KCl, we're going to move it down here. Okay, oops, okay. And then moles of KClO3, we're going to put right here. I'm trying to color code. I know, maybe that helps, maybe it doesn't. I don't know. All right, so see what I did? I just crossed them out. Right now, we're going to look for the numbers. Now, this mole-mole ratio up here comes from the balanced equation. So look above, right? There's 2 KClO3s and 2 KCl's. So it's 2 and 2. Now, you could put 1 and 1 if you wanted to, but you know what? We have calculators. Why not do it the same way every time? This way we don't have to think where they're coming from. If someone else sees your paper, that, well, why'd you get 1s? It's supposed to be a 2. I'm just keeping it that way. All right. Now, if you have grams and moles, if you have grams over moles or moles over grams, what this is meaning is how many grams does 1 mole weigh, right? Either top or bottom, it doesn't matter. The same thing holds true. You put 1 for moles, and then the grams, we have to add up the weights from the periodic table. So this is where you need your calculator to be handy dandy here. And I have to slide down a little bit and see if this works. Hey, there's my periodic table. There I am. So we're looking for K. K is right here. See it? So 39. Cl's over here, 35. And then we have 3 oxygens right here, 16. So we have, I'm going to get my calculator with my other hand here. So we have 39 plus 35 plus 16 times 3. I got 122, all right? And let's see if I can find it. Where is that paper at? I had it. Whoop, come here. There it is. So it's 122 grams. All right, now that's not hard to do. You just have to know how to do it, right? Okay, now we're ready for put it in the calculator. So in a calculator, again, you know, you have 2 over 2. You could ignore those if you want to. I'm going to put them in just for fun. Now, the best part is I already have 122 in my calculators on the top. So as long as it's on the top, I can start this way. So I have 122 times 2 divided by 2 times 2.75 equals. And I got 335.5. And that's grams of KClO3, right? It's always going to be this label. I hope that makes sense. Now, I started with this number because already in my calculator. That's why I did that. As long as it's on the top, right, you can do that. You can start with this 2 here, but then you're going to have to put multiplying in front of anything else on the top and divide by anything else on the bottom. You know, the order doesn't really matter as long as you multiply the tops, divide the bottoms. Okay. I might like to circle my answers. All right, now let's go down to this next one. And I think I'm going to stop this video after this one because I'm getting a little long and I know. I'll just do 3, and then I'll come back and do the next 3. All right. So Maddie's manufacturing of nitric acid. Okay. Sometimes, well, maybe I don't need it. Nitric acid is, whoops. The first step, I say there's no nitric acid in this equation. Okay, the first step in Maddie's manufacturing of nitric acid involves the catalytic oxidation of ammonia, according to the following unbalanced equation. How many moles of NO are formed if 824 grams of ammonia react? So I'm going to write that down on my thing already. I got my calculator in my hand already. I got to get that out of there. So this is 824 grams right here. Right? We're trying to find out how many moles of nitrous oxide here. Nitrous monoxide. Monoxide. Okay, so there's our thing. All right, we got to balance this equation. Look at that. Look at that. Ooh. Stay away from those oxygens till the end because they're split up over here. So that's one thing we want to do. Let me scoot over here closer so we can get a good look. So I'm starting here. Oops, why is my hand not on there? So I'm starting here with these hydrogens, right? So I have 3 hydrogens on this side. I have 2 on that side. Again, let's do a multiple of 6. So I'm going to make it 3, and I'm going to make it 2. Now, let's do this nitrogen here. I have 2 nitrogens now. I only have 1 here, so I need to put a 2 in front of that. Okay, now we can start adding up these oxygens. It's going to be ugly. It's going to be an odd number, so we're going to have to do a little trickery, okay? So we have 2 plus 3. So it's 5 oxygens on the right, and we have this darn 2 there, right? So let's just use that old trick, the half trick. So let's say what times 2 equals 5? Well, 2.5. Now, really, if you stop here and you use this equation like this, it will work, okay? It will work because the ratios are right. Now, if you want to get technical, and there's a lot of teachers you'll have who will just say, hey, you can't do that. And so I don't want you to fall into that thing where you stop early. So let's fix this up. So this is going to be a 4. This is going to be a 5. This is going to be a 4. All I'm doing is doubling it to get rid of the odd. Okay? And that's it. Okay? Now I have that balanced equation. Now we're ready to map. Let's map this out. Now eventually you're going to outgrow this map because you know how to do it. It's grams of given, moles of given, moles of unknown, grams of unknown. Okay? Again, we have grams and we're going to moles. All right? I'm just giving you different varieties away. So this is grams, and we're going to stop before we get to the end. So we're going to cut off this last step. Okay? Let's start here. 824 grams. NH3. Again, now we're going to moles, and it has to be moles of the same thing. It's still the unknown. Moles of NH3. And then finally, moles of the given, which is NO. All right? That's the pattern. Grams to moles, and we crossed out grams. So we're still in the same pattern. Now we have to cross out our labels. So grams of NH3, cross out. Moles of NH3, cross out. Okay, and now all we have to do is our math here. So what do we have? We have moles over grams. So the mole has to be 1 because we're trying to find out how many grams are in a mole. So we're going to use 1. I shouldn't say it has to be 1, but it's the easy way. Why not do things the easy way? So here's I gotta get back on the picture here. All right. So here's N, or H, right? So H is 1, N is 14. So it's NH3. So that's going to be 14 plus 1 plus 1 plus 1 plus 1 plus 1. So 17, right? So you probably knew that one, right? Maybe not. Okay, so here we go. So this is 17. Oops, hey, you're in the way. Okay, and so, oops, now I'm back. Okay, and so that's 17 grams there. All right, now the mole ratio comes from that balanced equation. So look, we have a 4, right? A 4, so the 4 is going to go right here. Right, the ammonia, the NH3 was 4, 4, 4. The NO is also 4 and 4, so that's going to be an easy one there. Okay, now, bumping into our calculator, make sure that you multiply the tops, divide by the bottoms. And so we have a guy in the way. There we go, that's better. Whoop, let's scoot over here. How about right there? How's that? So we have 824 divided by 17. Now, it's 4 over 4, so it's going to be like a 1. But times 4 divided by 4 equals, and I got 48.5. And that's moles of NO. Boom. Okay, so that's where I'm going to stop on this video, this section, and I will come back and I will do the rest here in a second. But if you don't need it, then don't use it. I'm going to post these answers too. So let's see here. I got to stop this video. This is the awkward Mr. Arnold doesn't know how to stop the video thing. Hey, there it is. Oh, it's only 20 minutes long already.